Hey mechatronics students, this is Andrew Dahlen, and I'm shooting this video to talk about one of the biggest parts that I've ever machined on the mill. So I thought I'd just take the time to show you guys how we set it up and how it was run. So let's switch over to the view of the mill. This is not going to fit inside the vise, so we have to position it, fixture our plate on the mill in a little bit different configuration. So our first step in this process is to make certain that this surface is clean. We don't want to have any chips that would affect the setup of the part. All right, we don't want to have anything underneath this. So that surface is clean, and in this case I'm going to opt to use some blocks that are going to go underneath the plate. So they'll lift it off here a little bit. That way I can drill holes and they won't go into the bed of the mill. They can go into this sacrificial block. That'll lift it up. In this case, it's 3/4 of an inch thick. So there again, these blocks need to be clean and they can't have any burrs that would cause them to stand up. So I've already filed the edges of these parts and deburred them. So they are good to go. In this case, another thing that I've done is to pre-drill some holes. So included in the design of the part, I was able to drill 6 holes, and they're designed to be used in this case as part of our fixture setup. We're going to be using these hold down T-nuts and threaded rod and screws. So again, we want to make sure that everything is clean and full, clear of any sort of chips or burrs. So we want to make sure both sides of this are good to go and that there's no burrs or anything that would cause it to stand up a little bit. So the part has been cleaned, and now we're going to get ready to set up our fixturing for it. So like I said, we're going to be using a lot of these T-nuts. So we'll position them, kind of get them in place here. It happens that between one slot to the next slot is 5 inches in space, so that's where those holes are drilled 5 inches apart. So we'll go ahead and get these guys clamped up, slid into place, and then we'll put those aluminum spacer blocks around this as well to help us get it in position. So that's good to go. Now I'm going to choose to put a block here, and I've got some more blocks coming in. You can see I've used these for other things, so they're a bit sacrificial. That's all good. I'm going to put a block there, a block on this side, and our last block. Actually, I'm going to switch this out, put this guy over here. It's a little bit wider. Okay, so there we go. That is ready for us to bolt the part onto. So let's see if we can get these guys aligned. And I think I'm going to just pause the video because this will take me a little bit of jockeying back and forth to get those lined up. I'll probably grab a tape measure and get these positioned in the right spot. Okay, I've got the blocks positioned, the bolts positioned about in the right spot. Happens that they're about 12 inches apart, so use a tape measure to try to get them pre-aligned and ready to go. And now the fun part, will this be able to slide on over those? It's going to require a little bit of finesse. We've got 1, 2, 3, 4. Aha! There we go. I was able to get all of those guys installed, and now I'm going to opt to use some washers, probably a couple of washers on each of these, and get it clamped up into position. So it looks like it's just going to be one washer. So at this point, this has a fair amount of wiggle room that it can move around on the mill table bed. So we're going to have to dial it in a similar way that we've dialed in a vise. So once we get these about secure, we're going to take a couple of quick measurements and see if we can't get this dialed in. We'll go ahead and throw a dial indicator on the head of the machine, and we'll basically follow this edge and check it out and see if it's ready to go. All right, this part happens to be a little bit bigger than what the mill can handle in terms of the Y movement in this direction. So technically this is I think it's a 9 by 49 mill or something like that, or 9 by 42. So 9 inches in this direction and 42 inches this direction. So that's not going to work very well in this case. We're going to have to move the whole head over. So right here, the center of the spindle cannot actually reach this edge. So as it is, the only way for it to reach that edge is for us to come over here and loosen up a few things and basically slide the whole head of the mill forward. So to do that, I guess I don't even need a wrench. We just grab these two and we can just move this handle and we can slide the front edge of this mill forward. I'm just going to make it so that it can just clear what we need it to over there, and double check it with our dropping the spindle down. Yes, it looks like in this case we've got a little bit of room over there. I don't need much, so I'm actually going to slide this back just a hair. Okay. That'll probably be enough room. They'll go ahead and lock this back down, and the machine is all set up, and we should be able to get our dial indicator across this front edge of the part. So now that the spindle can actually drop below the front edge of the part, since we slid it out, we'll be able to get the dial indicator positioned so that it's able to read this edge. And what we're going to want to do is get this edge to be straight all the way across. Right now it has a lot of slop to it, so we're going to use the dial indicator to get it in position. And typically with this, what I'll do is try to find the center of that slop on one side, you know, estimate it, and then we'll probably snug one side down a little bit, not very tight, and then that gives us still the ability on this side to basically dial it in and out. So what we're going to do is basically dial in on one edge. So I'll zoom in on the dial indicator. Actually, just give me a second here. I'm going to back up so we're right on the edge that I just tightened up. So we're going to spin this over and position that dial indicator so that it's pretty much on the by the bolt that we had just tightened up. And we'll be able to tell pretty quickly what we need to do to get it in position. Okay, now I'll zoom in on that dial indicator and we'll get a better look at what's going on. Okay, that looks pretty good. You can read the numbers anyway. So I'm going to position this straight up and down so you get a nice shot of it, and we'll go ahead and move our axes in until that dial indicator starts to read, and I'll try to get it set right on the 0 number. Okay, so you have a little bit of parallax here how you read it. When you look at straight on, you can see that it's 0. What you're seeing looks like about 99. So we basically crank this over and we want to get it 0 across that whole front edge. And right now I've traveled about, well, I'll go to the other bolt here, and that'll be about 12 inches of travel. Get the dial indicator so it's lined up with the other bolt, and then I want to get that position at 0. It's actually pretty good. I was surprised. So we have a bit of variation, but what I'm going to do is to bring this edge so that reads 0 again, and then go ahead and start tightening up the bolts and see where we're sitting. So we snugged up this bolt, had the dial indicator right in front of it, set it to 0, then moved over here, and basically using this as a pivot point, we were able to swing it in and out and get it dialed in. And that should be probably pretty good. I'm going to snug up 2 of the 6 bolts, and then we'll take a reading across that front edge and see if we've got it dialed in. So there's our dial, and as we move it across here, we can see some variations as that needle bounces around the edge a little bit, but it's still hovering around 0. I'm pretty happy with those numbers. Yes, it's pretty much centered around 0. So at this point, I'm pretty happy with the numbers. I've verified that this front edge of the part, when only the x-axis is moving in and out, this front edge of the part is pretty much at a 0 point. So I know that it's ready to go. I can go ahead and lock down all of those bolts. Okay, so we've got the front edge nicely lined up and dialed in, but I've now repositioned the dial indicator so that I can check this top surface and find out, is this top surface, you know, relatively flat, or did, when the bolts got cranked down, did they get warped or twist the plate somehow? So with this dial indicator in that position, I can go ahead and bring this up and check it out. So I'll zoom in on that dial. Whoa, bit too close there. And we're gonna raise the z-axis of the mill up until that dial hits, and try to find right on the 0 mark. And I'm hoping that this is flat relatively to a few thousandths as we move along. If it isn't, then I could actually shim things up and down to get it better dialed in. So looks like that needle has moved up a little bit. It was about 1 thousandths, a couple thousandths there. It's not bad. Again, this would be really fussy to have to get in there, loosen up the bolts, and try to shim this up and down. So I'm going to be pretty happy if it's within a few thousandths. All right. So looks like things are pretty decent. The needle's mostly staying up and down, and I'm going to call that just in the interest of time. It did fluctuate a little bit. There's some dips and valleys in here, but it's going to work for this project. All right, guys, so I went ahead and swapped out the drill chuck for a 3/4 inch end mill 2 flute, and I've got to set my RPMs for this. A neat feature over here on the digital readout, if we go over here to use these arrow buttons, it has calculator, RPMs. We've got the cheat sheets around the lab that show this, but in this case, it's pretty neat to be able to use this, and I use it quite frequently. So I've got a 3/4 inch cutter, and it's aluminum cuts at 300 feet per minute. So this is a calculator. The formulas that we use in the lab on those sheets, this will get you to the same point. So I want to be about 1500 RPMs on this mill while I'm getting it cut. Well, here we are, ready to get this guy trued up. Gonna fire it up and go ahead and just clean up that front edge. So I'm just gonna bring it in till it just starts to touch, because this block is only about 15 thousandths larger than the ideal finish dimension, so I don't have a lot of room to take material off. So I'm just starting to engage at this point. I'm gonna keep going till I get a nice clean cut. All right, just a couple more thou, and then we'll go ahead and clean this guy up all the way across. All right, I've got a lot of cutting to do, so I'll just pause it here. So I've got the first couple edges almost finished, but when I went around this corner for the short side, I ran out of travel in the y-axis. So I'm going to have to move the whole head straight backwards in order to accommodate for this, because I've got just a little bit, a couple inches, about an inch back here that I couldn't get, and then I've got to be able to clean up the whole back side of the part. So that's going to require me to shift the whole head backwards to accomplish that. So I'll get that taken care of, and we'll get this whole thing squared up. So interesting things happen when you have parts that are quite a bit larger than normal. We don't have a calipers large enough to measure in the shop right now between these 2 points to check that we are in tolerance. So what we can do is to grab a couple of these gauge blocks. This is a number 2, so it's a 2-inch, and this is a 4-inch gauge block. And we'll take this measurement with a combination of gauge blocks as well as the calipers. So I've got another block back here, and what we're going to do is basically push these together So they're nice and square and tight up against that edge. Then bring the caliper in and check that measurement. And in this case, it's right on the low end of the tolerance, but that's an interesting way to measure parts that are larger than the capacity of your caliper. All right, everything should be good and square on this block now. Sometimes I forget to hit record. Next up, we're going to be machining this slot that runs all the way along the block here. It's only about 1/8 of an inch deep. The dimensions up top there. I don't know if it's in the field of view. So we started machining on this and just taking away, popping that long groove all the way across, making chips. So this is about, it should be 1/8 of an inch deep. So I'm running at about 0.1 through this cut. So I've only got about 25 thousandths left for that final pass, and I'm staying away from the final edges as well. So I'm going to remove the majority of the material and then get back in there and get it very close to the final dimensions for our final passes. All right, so I've got a rough pass through here, and we're definitely away from where we should be in depth and everything. So I'm going to go ahead and check this out. I haven't moved the y-axis here, so we're going to check out and see where we're sitting. This is about, I don't know if I like that. We're going to switch the caliper for this mode. Going from this edge, should be about I need to be 2.503, and right now it's 2.470. So the difference between that is 32 thousandths. So I'm going to go ahead and move the mill, zero my Y, and then move the mill over just a little bit. So I've zeroed the y-axis, and then I'm just going to move it over so I get 32 thousandths more, and that should be good for that final pass. 31. There's my 32 thousandths. Go ahead and lock the y-axis in place. And now I've got to worry about the z-axis. So I'm just going to bring the knee of the mill up the rest of the distance, but I got to figure out where I'm sitting. So I'll take a couple measurements here. So I'm getting about 0.110, about the same there. So I'm getting, yeah, 0.110 across there, and I need to have it at 0.125 for its depth. So I need to raise the knee up 15 thousandths. I've done that, and now we're ready to take what could be our final pass across this cut here. So we're going to go ahead and put in lots of WD-40 across this, since we're cutting that aluminum that does a nice job of keeping it lubricated. So this should be our final pass, but what I'm going to do is to go into it for just a little bit, take my measurements, make sure it's right, and then if it looks good on the little bit that I cut here, I'll go ahead and do the entire pass. All right, so rather than mess up the entire cut, I'll just try and see if I've got it looking good at the very end. So from here to here, I should be 2.503. Double check that. I've got a few more thousandths to go. And then depth-wise, this might be a bit of a trick to get my caliper in there to read that. So much junk going on. Well, I'm not too worried about it. We're going to go ahead and cut this. All right, so we were able to hit our target here of 2.503 on that far edge, and now I've got the other edge, 1.497, that I'm trying to get set up. So over here, you've got the mill. I'm going to go ahead and to find that edge, I'm going to take a cut, and then it'll be close. I'm over the size that I need to be right now. Right now, this is measuring like 1.560. So I've got plenty of room here in this measurement. I need to get it down to about 1.497. So we'll fire up the mill, and what I'm going to do is basically get a pass where I know it's up to that line. There we go. So I'll have a 0 point here. And from there, I'm going to go ahead and zero the x-axis out so I can see, I'm sorry, the y-axis. So here's my y-axis. That I can hit 0, then go back to the screen here, figure out, well, how far did I actually cut in with the caliper? I need to hit 1.497, and I've got 532. Okay, so that's a difference of 32 plus 3, so 35 thousandths. I've got to move my y-axis in. So I'm going to go ahead and move that in 35 thousandths, and we'll go ahead and take that cut. Come on, 35 thou. There you go. Go ahead and lock in my y-axis, and we'll take this cut, and it might be our last one on this notch. Again, applying a whole bunch of WD-40. So we'll take it a little bit here, shut it off, and measure it. And that's a good way to go about this. Rather than screwing up the entire cut, I had the potential to just screw up this little bit. 1.497, I've got 1.495, so it's only 2 thousandths away from where I'd like to see it, which is really good. So we're going to go ahead and finish up this cut. Okay, so we applied a whole bunch of WD-40 coolant on here, cutting fluid, and we are ready to go. This could be our final pass on this particular slot. So I'm going to take a nice slow cut all the way across. So just have a very nice controlled rate of speed all the way across the part. So we're good to go. Okay, the next slot that we have to cut is shown right here, and this has a geometric dimension tolerance associated with it. So relative to datums A, B, and C, there's datum A, B, and datum C is over here on the other side of the drawing. Basically, this needs to be parallel location-wise from that edge down to this edge down here within a couple of thousandths. So this is going to be really important. It's for the majority of our setup. So we're going to go ahead and pay particular attention to this. The first thing that we're going to do is just to get our cutter positioned so that it's, again, away from all those lines where it needs to be. Meaning instead of, it's supposed to be 9.547 inches away, so we're going to have it go well far from that line, and then take some measurements as we get closer to it. So 9.547, we'll start with it probably about 9 5/8, 9.625 away from there. Go ahead and hog the majority of the material away and keep it, instead of having it 0.625 for that thickness, we'll aim to see that it's a bit large from there as well. So we'll just take it in a few passes. All right, so here we are hogging that away. This is definitely away from the final lines, the final dimensions. So it's proud of all those lines, lots of space. I'm taking a pass across here at 0.1 inches deep, and the final pass should be close to an eighth of an inch deep at 0.125. So I'm about 25 thousandths away from where I should be with this cut. All right. Okay, so the slot is almost done. In order to get my measurement, I'm having to do that trick again with our gauge blocks. I've got a 4-inch gauge block, and its edges are nice and clean, and I've kind of cleaned off some of the chips in this area. So in order for me to measure this distance from this edge to the edge of the part out here, I'm using the caliper and these gauge blocks, and I just made a pass here a little while ago. So this is right now at 5.557, and I need to hit 5.547. So it's only 10 thousandths off from where we need to be. So that's good news. Again, this is the dimension that we're trying to hit here, 9.547, and I'm getting 9.557. So I'm just a little bit proud of that line, and I've zeroed my Y. So then all I should have to do is just bring this in an additional, wrong way, 10 thousandths, and that should be really, really close to our 547. So I'm actually going to go, I kind of like that number. I'm just going to be a little bit large of there, about a thousandths off from where I want to be. And let's make this cut. So here we go. And again, I'm going to do that same trick where I just take a little bit and use that, kind of check it out at the end, verify that that is good before I make the whole cut and mess up the entire part. Okay, so I've removed all the chips, and if I get my gauge blocks and my measurements in there one more time on this end, one 9.547. Come on. All right. This is an interesting setup, so okay, so this is showing 5.555, so it's about 3 thousandths away from the target. That's not bad. So I'm going to go ahead, make that small 3 thousandths adjustment, and we'll finish this pass. Well, that's it. I was able to get both of the grooves installed, milled in place, and everything is looking pretty darn good. When I did my final dimension check over here to figure out, how was I doing on that 9.547, 9.547. So when I get the final dimension here, 9.5, come on. This is a kind of a tricky dimension to get. I'm at 9.475, so I'm 5/10 over. Very happy with that measurement there. So I'm within that 2 thousandths window that I was aiming for, and very, very good. So that was a lot of messing around here to get a very large part completed. And it's not done yet, because when you look at the drawing, you can see we've got a whole pile of different holes that need to be drilled. But that's a pretty straightforward process, and I'm going to exclude that from the video. We simply find our edges here and then go through and drill a whole bunch of holes. So there's nothing really new or different exciting about that. But at any rate, I thought you might enjoy some of the weird things that you run into when you're dealing with a much larger part. And we had to do some creative measurement with the gauge blocks in there. And we had to do some moving around in order to get this set up. And it was also a nice example of being able to use or fixture a part on the mill without the use of a vise. So many times we just see, oh, we just throw it in the vise and away we go. So we actually had to set this up, get it dialed in, and hopefully you guys appreciate the additional setup and just seeing, what does it take when you have something that's out of the ordinary, something that doesn't fit in a milling vise. So there you have it. We shall see you guys again next time. Take care.